So this is the assignment which we have. Its basic setting out is given over here in this little sketch at the bottom. You can see that you basically have a base of 6 meters and the column heights are 5,000 inclined, and this distance is given as 4,000, so the columns are inclined inwards. You've got two HEA 300 columns. You're basically focusing on the connection over here. So you have a T140 profile going like that, connecting to the working point, and you've got a back-to-back angle 70 by 7 also connecting to the same working point. But both the T as well as the back-to-back angles have been shifted. So if you come over here, you see that this is the working point, the middle of these two end plates. Let's take a look at what it looks like. This is the 3D picture. There's the column coming up, there's the column continuing. The middle of these two end plates is the working point, which is this point over here. And both the incoming back-to-back angle as well as the T140, their working points are actually over here, but the back-to-back angle has been shifted 100 millimeters down from that working point, both the start and the end. And the T140, only the end over here, the other end at the bottom of the base plate on the other side, next to the base plate, that's not been shifted. But this one has been shifted once again 100 millimeters, but along the column. So both the back-to-back angle as well as the T have been shifted by 100 millimeters in different ways. This one goes down 100, this one goes down 100 along the column. Then your back-to-back angle is kind of brought close to the edge of the outer edge of the column by 10 millimeters. That's the starting point. And you've got distances for these two bolts over here, and that's the final distance to the edge of the plate as well. The basic idea over here being that this is what the gusset plate looks like. The gusset plate has been drawn over there separately as well. All these are reference dimensions. They will come out automatically if we follow these dimensions. So you see that this one has been pulled back 10 millimeters. The T has been pulled back 10 millimeters from where it's about to hit the back-to-back angle, and also 10 millimeters from where it's about to hit the column, the edge of the column. And what's of note over here is that this line, this outer line of the column, is parallel to this line of bolts, which is also parallel to this line of bolts, which is also parallel to the outer edge of the gusset plate. So basically this column, this line, and this line, they're all parallel. You can see over here parallel lines, this outer edge of the column, this line of the bolts, this line of the bolts, and the outer edge of the gusset plate itself. All the notes are given over here. We start off basically by setting up this stop back-to-back angle, because you're given all the distances, and once you create those bolts and everything over there, you can then create these parallel lines. Once you have the location of this bolt, you can create this parallel line. Once you have the location of this bolt, you can create that parallel line. And then we also know that the gusset plate ends with an edge distance of 40. This angle of the gusset plate is 90. This angle of the gusset plate is 90. So basically all the information is given. All you need to do is just follow up the start from here. And then of course there's the stop where the end plates, the two end plates connect the columns. The gusset plate has a thickness of 20 millimeters. These end plates also have thicknesses of 20 millimeters. These bolts are M16 bolts because their holes are 18 millimeter holes. The bolts in the end plates, however, are 20 millimeter bolts because their holes are 22 millimeters, as shown over here. So this is what we will be attempting to do. If we go to the model, this is what it will look like once we are done with it. Once we model it, there'll be the column, there'll be two end plates, there'll be this gusset plate in the center. From the side, you can see how it's been cut. like that. It's been pulled back. It's going to be cut like that, cut like that. These lines will be parallel to this line and this line. That's basically the requirement for this assignment. So let's start by setting out the system as shown over here in this little sketch. We'll enter the columns incline. The bottom is 6,000, the top is 4,000. So we'll just enter a vertical column and then move it 1,000 to the left to get the basics done. So let's open a model. This grid is 6,000 as needed. Let's just input a column like that. This is the correct orientation. What we can do is we can zoom in and select this node, right click and say move linear, 1,000 in the X direction, like that. Say move, and that's the alignment, that's the inclination which we want. We can just go in and copy it to the other side, go like that, copy it to the other side. We can now actually copy this column because this will be working over here. So what we can do is we can select this column and copy it linearly from there to there. So the Z is 5,000. That length becomes 5,100. That's fine. So we just copy it like that. So the two columns exist now. Now we can enter the horizontal brace, which is the back-to-back angle, if you remember. You just go in and enter it like that. We can double-click on the brace, change it to a twin profile, say apply, get it out of the way, just go to the twin back-to-back angles. This was 70 by 7, if I recall. And the distance between the two would be 20 because the gusset plate was 20 millimeters. So we do that, and then we just rotate this a couple of times to get it to the right orientation. Is this what we need? No, we need to press Control W twice so that the top gets aligned with the working point. And then there's a further alignment, if you remember. There's a further change of there's a further shift of 100 millimeters. So the top of the back-to-back angle is 100 millimeters down from the working point of the columns. So for that, all we need to do is just double-click on this one, go over here and say behind 100, and that will basically bring it to the point where it needs to be. And for the other vertical brace, let's just quickly go in and enter that to the same working point, this one, the same working point as the column initially, and then we can just directly type in T140 over there, like that. Now it needs to be brought. Let's press Control W. No, this is not the one we want, so press it twice again to bring it back. Control E. Yes, that's the correct one. And so it's centered now, but now it needs to be moved another 10 because the gusset plate thickness is 20. So we will move it a further 10 so that it gets to the right point. So now you can see that the back is now coinciding with that angle, as you can see. It's still not at the right place because we know that the working point of this T is actually shifted 100 millimeters along the line of the column. So it needs to be, it's not a vertical shift, it's along the line of the column. So what we can do for that is we can just right click and put our work plane to object like that. Now we can see that the X direction is along the column. The T is correctly oriented. All it needs is the shift. So we select it. We go and select this blob handle, which is to shift the working points while keeping the definition intact. So we just select that like that. And in the X direction, we need to give it a minus 100, like that. So this one is moved X. Let's go and see what our view on line 1 looks like. Let's put the work plane back in global. Go to view on line 1. like that. And over here, we will see that this one is also shifted to, so the top and the middle points are coinciding. This one is 100 along, and the other one is 100 below that point. So this is exactly what we wanted, and we'll continue from here. So let's begin by creating these end plates so that we get those out of the way, because the gusset plate will be going around them. So let's begin by entering these end plates. If you notice, 200 millimeters to the left of the working point and 200 to the right, so the total length is 400, and it's 400 in both directions, and the thickness is 20. So we go to our view on line 1, we zoom in over here. This is the middle of those plates. So all we need to do is go to our sectional plate command, right click, hover over this working point, say enter, and say dx minus 200, like that. And then hover over the same point and say dx 200, like that. And then right click twice to get out of the command, select the plate, press Ctrl W twice to bring it down. So that's one of them done. We can double click on it and give the other dimension as 400 as well, like that. And we can go to the sectional plate command again, right click, hover over the same point, say dx minus 200, and then hover over the same point and say dx 200, like that. We've got the other plate now. Select that, press Ctrl W once, double click on it, make this one 400, click on OK, and that should basically, if you go back to the 3D view, we should be able to see that the two end plates are in there. Obviously, the columns are not fitted according to that, but the end plates are there. So to fit the columns, let's just get that out of the way as well. We need this column to be fitted along the top, and we need the bottom column to be fitted along the bottom. So we can go to our edit menu, go to the cut command over here, and there's a fitting with 2 points, and there's also a fitting with a surface. Let's use the fitting with the surface. That's easier to use in some cases. So we click on that, select the top column, and now it's asking for a surface. So I want the top surface of that plate. I hover over that point, but I can't seem to select it. So I leave the mouse over there, click on the control key once, and it toggles to the other surface. And now I can click the mouse button, and you can see that the column has been fitted. Now I do the same with the bottom one. Hover over this line, press Control once, twice, get to that surface, and there we go. So the two columns have now been fitted, one to the bottom of the end plate and one to the top of the end plate. Now let's start working on this, the basics, the points which will form the basis for the gusset plate. So the first thing we notice is that we want to pull back this member. Let's zoom in to 10 millimeters along this direction before it hits the outer edge of the column. So for that, what we can do is we can zoom in and go to our extension point, for example, click on the shift key, say minus 10, say OK. Hover over any point on this line, press the control key so that we can snap to it. Then this, once we snap to this point and we click on it, we will get the point which is 10 millimeters away from that point. Now you just right click to get out of the command, and you need to pull this back. We can actually measure it as well. Let me double click on that. It doesn't have any offsets at the moment. But what we can do is we want to basically measure it this distance, but instead of entering that awkward number, we just select this blob over here, this one, and we will say select distance, zoom in to select this point, and then that point, that's the 142.97 whatever, and we say move, and that one is pulled back, and that awkward offset is now inputted into the end offset over here. So we've got this one in place, and now we can continue with the bolt locations and everything. Now let's focus on these two cuts on the sides. This cut is done in a way that it's 10 millimeters from the edge of the back-to-back angle, and this inclined one is done in a way that it's 10 millimeters from the edge of the column. So we go back to the model. We can go in and go to the edit menu and choose plane cut by surface this time. Select this vertical brace, and then basically select this surface, the bottom surface, to press the control key to toggle to that, like that. So it's basically created a cut over there. Let's turn on the cut so we can see it. Let's double click on this cut and give it a distance of minus 10 millimeters, like that. So it pulls it down, and we need another one along the side of the column. So we go back to plane cut by surface, select the same brace, select this edge of the column, can't select it, press control key, and once again the control key until we get it, and there's the cut. Now we double click on the cut and give it the same minus 10, and that should basically turn off the cuts. You will see that this is basically what we wanted. Now let's focus on this construction line and these 2 points where the bolts will be, and also this point has been given as the. So let's just try to create these points. First, let's create this construction line, which is 35 millimeters below the top. So we go to the model, we go to our construction line command, and we can just start from here and just first of all press the control key to hover over any point over there, and then we can just select this construction line and move it linearly minus 35. So we now have that construction line over there. Let's go back to the drawing. This first bolt is at a distance of 35, like that, and then another 60, and then another 37.5. So what we can do is, so remember the 35, 60. Let's go back to the model. Let's go to our extension points. Click on the shift key, say minus 35, minus 60, and minus 37.5, which was the other point. Just click on that, just select any point along this line, and then this point, so that we get those 3 points. This is the first point of the bolt, this is the second bolt, and this is where the gusset will be ending. Now let's go back and create these. So we know that this line, these bolts will be placed at points where there's a parallel line. This line is basically parallel to this one. That information has been given over here. The parallel lines, this inner edge of the column, this bolt line, and the inner edge of the gusset plate, they're all parallel lines. So what we can do for that is just create a line along the inner edge of the column first. So what we could do is we could go to construction lines and just create any line like that, and just select that line. If you've selected, yes, we've selected it, and we could just say copy linear, and we could just go something like go from here to here, copy like that. In fact, let's use the other command, copy, and say from here to here, and also till there. So we have those parallel lines now. This would be the line of the bolts, this would be the line of the bolts over here, and this would be the inner line of the gusset itself. Now let's create these lines. These lines, the profile is T140, which the total flange width is 140, and half of that is 70, and these bolt lines are in the middle of that, so it's 35 from that edge and 35 from that edge. So what we can do is we just need to create these 2 lines, 35 from that edge and 35 from that edge. So let's go back to the model and create a construction line first along. Just click on the control key, let's zoom in so we're sure we're not selecting something incorrect. There we go. And now we just need to move it 35 in this direction. So what we need to do is we can set our work plane to this object, the T over here. So this becomes the X and this becomes the Z. You can see that. Now we can just select this line and say maybe copy, or let's say move first, because we don't need the outer edge. And in the Z direction, we can say minus 35, move. So that's the first bolt line, and then we can copy it to the other one. This time it would be minus 70, like that. So we have both those bolt lines. So we know the exact position of the bolts, how the bolts will be modeled in this case. Now we notice that the edge of the gusset plate is actually 40 millimeters below this bolt point in the direction of this line, and then it'll be a perpendicular projection to the column because we want this to be 90 degrees as well as this one to be 90 degrees. So let's first create this 40 millimeter point. And for the top, we notice that this thing is basically just a chamfer of 50 millimeters each. We'll just extend these 2 points to get the corner point of the plate. So let's start with this bottom one, the 40 millimeters from the bottom hole, bottom bolt. So this is where the bolt would be. So what we need is this is where the bottom bolt would be. We need to go along this line 40 millimeters. Let's put the work plane back to normal and go to our extension line. Extension point, press shift and press 40, click on 40, and this is the bolt which we want. So this is where it's going to come in. Now we just need to project this point to the inner web of the column. Let's put our work plane over here. Let's go to our point commands once again and use the projected point. And we need to select this inner web line. So we click on the control key to select any 2 points over there. Then we basically zoom in and we select this point over here. So we get this point, which will be the gusset point. As far as the top point of the gusset is concerned, that's basically the intersection of this line versus this line. So we can do that as well while we're at it. We can do intersection points, and we'll take the bottom of this base plate like that, and then we'll just take any 2 lines, 2 points on this line like that, and we get this point as well. So basically our points for the gusset plate are now ready. In fact, that's not correct. We need one more point. We've got this point, but this is not the edge of the this is not the corner point of the gusset plate. If you go to the drawing, you'll see this is this point. We need this point as the corner. So that's basically an extension of that. Is the intersection of this line versus this line to get this corner point of the gusset. So we just go back in there. We go to intersection points. We can just select any 2 points along this line, and then we can select this point and this point over there, so that we get this point, which is now the corner point of the gusset. Now we can quickly create our gusset plate. Let's go to the steel menu, go to the contour plate command. Just zoom in over there. We can snap to this point, snap to this point, come down, snap to this point, go in there, snap to this point along the web, and go back and finish the gusset plate. As far as this point was concerned, it had a chamfer of 50 and 50, so we can just click on this, go to the chamfer, type 1, give it a chamfer of 50 and 50, like that. So that's done, and the thickness of the plate should be 20 millimeters, so that's correct as well. So we can go back in to the 3D view like that and see what we have done. That's what it looks like, and it doesn't seem to be clashing with anything. So we've placed the gusset plate where we wanted to place it. Now let's just start creating our bolts. We can start off with these M16 bolts. Let's go to the model. Let's go to the other view on line 1. It's always better to work with 2D views. Let's go to the bolt with auto coordinate system. Select the gusset plate, select the back-to-back angle, right click, click on this point and this point as the origin and the X direction, double click on that, change it into an M16 bolt with 2 millimeter hole tolerance, and the position is 0 to 60, that's fine. We can do the same for the other bolts as well. First of all, this bolt, these 4 bolts will be 2 sets, 2 bolts over here and 2 bolts over here. We can't create all 4 in a single go. because they're not square, as you can see. The angle is sheared between them. So we select the gusset plate once again. We select the T profile, right click. We select this point and the X direction. Once again, we can make it match up with the other one for the M16, but this distance will need to be entered manually, because in the drawing also, if you notice, whatever these parallel lines give us, this distance is roughly around 70.2. Let's find out exactly what it is. Let's right click and say measure from the middle to this point. It's 70.160912. 70.160912. So I double click on that. Instead of the 60, I say 70.160912. So that it exactly sits at that point. And once I'm happy with that, I can select this and say copy linear from there to this point, because it's the same bolt. Basically, just be copied, and that should now give us the bolts. Let's just click on Control D once, so this we can see better what we've done. Yes, this is exactly what we wanted. We can see that this line is a line which is parallel to this line, and this line is parallel to that one, and all these lines are now parallel to each other. Now we are basically left with this little chamfer which we need to give to the plate, the rounded one, and also the bolts between the end plates. So the bolts between the end plates, let's first create them. Let's give the chamfer and create the bolts, and then we'll modify the distances. So we go back to this mode, we select the plate, we select this point, give it a rounded chamfer of say 35. You can assume any reasonable value, and that's fine. And now we can focus on creating the bolts on the two end plates. So for that, I'm going to show it over here like that. So we can go to the bolt command, and we can use the one with the auto coordinate system, because there's at least one plate involved in the bolting. So I'll select this plate and this plate, right click, and then I'm going to just select the midpoint of that and click on Alt D and click on the midpoint on the other side, and I'll get my basic bolts inside like that. And now what I can do is I can actually move the origin to the middle. So once the origin is in the middle, then I can probably define it better. So I can select that, and I can say move linear from this point to the middle. So it's 200, and you move them like that, and then you can open them up. And let's go back to the drawing and see what the numbers look like. So in the X direction, the numbers are 0 and 120. So let's do that first. So this was M20 bolt. The tolerance should be 2 millimeters. This one should be 0 and 120, like that. Let's do that. And then we can choose the middle alignment for the X direction. So they come to the middle now. You can see that. But now I need the Y directions, the Y coordinates as well. Go back to the drawing. The Y coordinates are 0, 70, 140, 70. So 0 is the absolute value. Let's just give that 70, 140, and 70. Let's go back 0, 70, 140, 70, like that. Say apply. And now I'm going to put the middle option for the Y direction as well. So that is basically going to create my bolts on the two sides. So very quickly, I've managed to create my gusset plate with all the constraints given in the drawing. I've managed to create my bolts in such a way that these lines are parallel. I'll just repeat that this bolt and this bolt need to be separate IDs, because they're sheared. If they were rectangular, if it was a rectangular grid, then we could have made just one ID. But since it's not, we need to keep them separate. Now, there's one little thing which I want to mention, which you need to be careful about. If we zoom into these bolts, you see they look quite fine. This is the head, and this is the other side, and you've got the nut and everything. But these bolts over here look a bit strange. It seems like they haven't gone through the full length of the twin member. And this can happen because of the cut depth. Sometimes the cut depth is insufficient. You can change that default to a slightly bigger number, which is basically the amount of distance it needs to traverse to get to the other side. So the head side is okay, but it hasn't really come out of the other side. So basically it's managed to find the first profile, the plate, but not the second one on the other side. So what you can do for that is if you just double click on this one and go to settings over here, and we change the default of the cut depth from 50 to maybe 100 over here would be fine, like this. And when we say okay, you will see that this pole kind of jumps out and it's now going through both. It was actually going through both IDs because this is one ID and that is one ID as well, but it wasn't going through the full length of this ID because of the cut depth limitation. So with that now, we have managed to finalize this connection.